Today we are going to do 6.3 solving trig equations. Solving involves finding what value makes the statement true. This is different from 6.2 because we were doing inverse function, which is operation. So we're just looking at what makes the statement true. We're not going to go over the first quadrant because you should be studying that on your own and you have the unit circle with you. But the idea is that we are looking for all the angles in which make it true. Now, because the unit circle or our circle can go around and around and around, we are going to look at our restrictions as the whole circle, so 0 to 2 pi. Okay, we are going to keep the value of 0, but go into 2 pi, but not 2 pi. Okay, that will make sense once we get down below. So you need your unit circle with you, so you can check. We are finding what values have sine of that value equals 1/2. So on your whole unit circle, you are looking for sine of 1/2. And remember, sine is the second part of the quadrant, or coordinate. So we have 1/2 right here. And if you keep going around and around, we get 1/2 right here. So there are two possible answers that make this statement true. You have to have both of those answers down to get credit. So pi over 6 and 5 pi over 6. Your answers will be in radians, not degrees. All right. B, cosine of what is -1. So we want to find out where the first coordinate is -1. If we keep going around our unit circle, we find that the only answer is pi. On C, this is what you want to do is make sure it looks like something that we can find on our unit circle. So cosecant can be changed into what? 1 over sine. And if you look, we can do the reciprocal and flipping both sides, and we end up looking at sine x equals square root of 3 over 2. So on your circle, unit circle right now, find what values make this true. Sine, the second part of the coordinate, square root of 3 over 2. There's one. But don't forget we have another value right there. So it's pi over 3 and 2 pi over 3. All right, let's change the page. Now, when we don't have values on the unit circle, you're going to use technology. We're not going to go over this right now because we are trying to do all this trig stuff without a calculator at the moment. So I'm going to have you skip A and B right now. What we are going to do is keep finding out what values make the statement true. But in some cases, like example 3, we're going to have to do some solving before we can look at our unit circle. So if we want to get the trig function of x by itself to be able to use the unit circle, what do we need to get rid of first? We need to add 1 to both sides. So we end up with 2 sine x equals 1. Now we have to get rid of 2, so we divide by 2. We end up with sine x, sorry that it's not focused, guys, equals 1/2. Get this better. There we go. So when you look at your unit circle now, which actually we did on the other page, where is sine equaled 1/2, we get pi over 6 and 5 pi over 6. So x equals pi over 6 and 5 pi over 6. Again, you need both answers. Some other ways that we are going to be able to solve are like B and C. So A was kind of our, I guess, level 1 for solving. I wish this would focus. There we go. Alright, what I want you to do is look closely at B right now. Can you recognize something? Can we change it into something else? If you notice, we've seen something like this before, but usually we see it as 2x squared minus x minus 1. So of course, what do you think we're going to do next? We are going to factor. Okay. My suggestion to you is if you can't recognize it right here, put it in just x's and then factor. I'm going to have you guys factor this on your own since you should be able to do so. When you factor, you end up getting 2x plus 1 times x minus 1. But of course, according to our original question, we did not have x, we had cosine x. So what I'm going to do is replace our x's with cosine. So actually I have 2 cosine x plus 1 times cosine x minus 1. Okay. Now, because we have 2 parts, I'm actually going to split because, of course, we want to set this equal to 0 and this one equal to 0. So I have 2 cosine x plus 1 equals 0. And I have cosine x minus 1 equals 0. I'm going to solve for the trig function. So when I do that, I have to subtract 1 from both sides, giving us 2 cosine x equals negative 1. Divide by 2, we get cosine x equals negative 1/2. And then we have to solve for the other one, which we're going to add 1 to both sides. So we get cosine x equals 1. So I'm going to look for all of these terms. There should be 2 values for the negative 1/2, and there should be 1 value for the 1. I'll look for the negative 1/2 first. So negative 1/2, we have 2 pi over 3 and 7 pi over 6. Actually, I did that wrong for 7 pi over 6 because I looked at the sign. I need to look for the cosine, right? So it's actually 4 pi over 3. So we have 2 pi over 3 and 4 pi over 3. Now that concludes the negative 1/2. So I still have to find the 1. Where is cosine 1? It's at 0. Now, remember how before we said that this is 2 values, right? It's 0 and 2 pi. But in our interval, we're including 0, but not 2 pi. There was a parenthesis around the 2 pi. So when you get to something like this, all we're going to do is put down 0. Okay. All right. This one looks a little bit different. Definitely not factoring, and we have more than one trig function, so we can't just isolate one. The first thing you're going to do is move everything over to set it equal to 0. So we get 4 cosine squared x sine x minus 3 sine x equals 0. Can anyone recognize what we might do next? If you see, they both have a sign, so we're going to factor that out. Minus 3 equals 0. So just like we did in the last one, we have two parts that we're setting equal to 0. So I'm going to set sine x equal to 0. And I'm going to set 4 cosine squared x minus 3 equal to 0. Sine x equals 0 is already solved, so we don't have to do anything with that. But this one, we're going to add the 3 to both sides. Divide by 4. Now this is cosine squared, so how do you get rid of a square? We take the square root. What is the square root of 4? It is 2. Now, when we take the square root of both sides, because we are solving, how many answers are we actually getting? We're getting plus and minus. So there are a lot of values for this. First thing we're going to do is find that sine of 0. Sine is the second part of the coordinate, so sine of 0 is at 0 and at pi. So our first values are 0 and pi. Of course, this comes from the sine. Now with the cosine, we're looking for where it's plus and minus. So technically there'd be 4 spots where it's square root of 3 over 2. So we've got pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So for C, there are 6 answers that would make this statement true. Be careful about that plus or minus. That's what most people forget. Alright, now we need our calculator. We're going to do a story problem that allows us to find the answer to this, because it's not so easily to solve just by your normal algebra. So we're going to use graphing on the graphing calculator. So a heater turns on in a home when the outside temperature is below 45 degrees Fahrenheit. During the middle of March in Salt Lake City, you can model the outside temperature in degrees using this function, where T is the number of hours past noon. Okay. During which hours is the heater heating the home? So what we're going to do is we're looking at where our function is less than 45. And what we're going to do is put the function, the first part, into y1 and the second part into y2. Now, what I want you to keep in mind is that that t goes with the pi over 12. So, 43 plus 9.5 cosine pi over 12. So I'm going to go pi over 12. And we don't have t, so we'll do x. So see how I put the parentheses around the pi over 12? Okay, and then I put that in Y2. It's okay. Either one's fine. And then 45. So this is going to graph where it equals. But of course, what we're looking for is where it's below 45. So in our window, we're talking about 24 hours because, sorry, it froze. We're talking about 24 hours. So I'm just doing the negative so I can see part of the graph. But we're going up to 24 hours. And we want where it's below 45. So I'm going to put 40 and 50 because it's right in the middle of my graph. So now I see that it is below 45 degrees right under 45. So the heater is going to be on between this point and this point. Does anyone remember how to find the intersection of your points? Remember, it's second trace, go down to your intersection, and then you want that flashing dot on the intersection. So it starts 5.19 hours after noon. And let's get that other intersection. So you're going to move your flashing dot all the way to the other one. And we get 18.81. Now, of course, 18.81, that's going to be past midnight, things like that. Just be careful with that. But I'm not worried too much about what actual hour it is, but we know how many hours past noon, so from here to here. All right, you can go get your homework and start practicing these concepts.